channel. I will start first day lecture central force motion. Central force motion. Central force motion. A central force motion. A central force. A central force is expressed as F equals to Fr unit vector, where plus sign indicate that repulsive force, and minus sign used for attractive force. Central force features of central forces. First, central forces are conservative. Central forces are conservative, comma, therefore total energy of the particle moving under a central force is conserved. Second important points: torque about central center of force is zero. Therefore, angular momentum about center of force is conserved. This implies that central force motion is a plane motion. Central force motion is a planar motion. Third point, I will discuss. Aerial velocity is constant. Aerial velocity is constant. Aerial velocity is constant. That is area swept by. That is area swept by line joining. Area swept by the line joining the particle to the center of force per unit time is constant. dA upon में dt equals to constant. Relation between angular momentum and aerial velocity. Relation between angular momentum and aerial velocity. Central force motion is a planar motion. We know that central force motion is a planar motion. Therefore, velocity of a particle is v vector equals to r unit vector theta unit vector r theta dot. Angular momentum of a particle about the center. Angular momentum of a particle about center O is here. F force applied along the center, F force applied along the center O at this point. We know that L equals to angular linear momentum L equals to m v theta or r, and also written the velocity r in m r, velocity is also written as r theta dot and r, that is m r square theta dot. And so L equals to m r square theta dot. Here r square theta dot equals to L by m. We write. So aerial velocity, aerial velocity, aerial velocity dA upon dt equals to half r square del theta upon del t, that means half r square del theta upon del t, that means half r square theta dot. From expression of equation A, aerial velocity equal to half r square theta dot equals to L upon m, that means L upon 2. That means aerial velocity will be equal to L upon 2m. Differential equation of orbit. Differential equation of orbit. Acceleration of a particle. Acceleration of a particle. Acceleration of a particle moving in a plane. Acceleration of a particle moving in a plane can be expressed in plane theta angle. A vector equals to r double dot minus r theta dot chi square r unit vector plus 2 r dot theta unit vector plus r theta double dot theta unit vector 2r dot theta dot plus r theta dot theta unit vector. Therefore in central motion central force motion Newton's equation is F equal to mass into acceleration. Therefore F r unit vector equals to m r r double dot minus r theta dot का square r theta dot का square r unit vector plus 2 r dot theta dot plus r theta dot theta unit vector. Therefore equating coefficient of r equating coefficient of r unit vector and theta unit vector, we will get therefore comparing coefficient of r unit vector and theta unit vector we will get from left side. So 2 here 2 r dot theta dot plus r theta double dot equal to 0 and r double dot m r double dot minus r theta double dot का square equal to fr. Let me equation first and second. Equation first can also obtained by equation first from equation first from equation first can also be obtained by differentiating equation first can also be obtained by differentiating L is equal to mr square theta dot. Therefore, it implies constancy of angular momentum. Therefore, it implies constancy of angular momentum. Equation second is differential equation for the dynamics of particle under central force. Under central force. 2 we obtain differential equation. Of orbit. We must remove time from equation second. We introduce a new variable. We introduce new variable u equals to 1 by r and theta dot equals to L by mr square. Here u equals to 1 by r, that means here L upon by m u square. Okay, so we will write differential equation of orbit. We will write differential equation of orbit. That means d square u by d theta square plus u equals to m fr upon l square u square minus here equation third. Okay, and also from equation third there is the differential equation of the orbit. This is this equation is a differential equation of orbit. Differential equation of orbit. Now the above the equation is mostly used for the above equation is mostly used for a we find FR when the equation of orbit of orbit is given. The equation of orbit is given. That is relation between relation between R and theta is given here, r and theta is given, then fr can be found, can be found. दूसरा, if fr is given, then to find equation of the orbit, find equation of the orbit. Question first, I will discuss. Question first, equation of orbit of a particle. Question first, equation of the orbit, equation of the orbit of a particle, equation of the orbit of a particle under central force, under central force is r theta equals to beta, where beta is a constant. Beta is constant. Find the force acting on the particle. Find the force acting on the particle. Find the force acting on the particle. Solution, given central force r theta equals to beta, then r equals to beta upon theta, and also there we write in terms of u, then u equals to, that means u equals to 1 upon map, that means theta upon beta. Okay, इसलिए here del square u upon del theta, del square u upon del theta square equals to 0. Okay, इसलिए डिफरेंशियल इक्वेशन ऑफ ऑर्बिट, so we can write differential equation of the orbit will be here d square u upon v d theta square plus u equals to minus m f r upon l square u square. Here put 0 plus u equals to minus f r upon l square u square. Okay, here we will obtain the result f r is equals to l square u square into u upon minus m f r is equals to minus l square u cube upon m. So also write f r equals to minus l square upon r cube into m. That means find the central force acting on the part. That means central force. This is the central force. This is the central force. Central force. This is the central force. Second question I will discuss equation of orbit of a particle. This next question. Equation of a orbit of a particle moving a central force is r to the power n equals to a cos n theta. Find the force on the particle. I will discuss second question for central force motion. Second question I discuss about a central force. questions. Second, the equation of orbit of a particle. Equation of orbit of a particle. Orbit of a particle. Equation of a orbit of a particle moving under a central force. Moving under a central force. Moving under a central force. Central force r to the power n equal to a cos n theta. A cos n theta. Find the force on the particle. Find the force on the particle. Find the force on the particle. Solution. Given r to the power n equals to a cos n theta. Given that a cos n theta, and also we can written in the form of u. So here u to the power n equals to 1 upon me a cos n theta equals to a 1 upon me sec n theta. Okay. Here taking log both sides. Here taking, let equation first. Taking log both sides of equation a, that means u to the power n, that means n log u equal to log 1 upon me a plus log sec n theta. Okay, then differentiate with respect to theta. Differentiate with respect to theta. We will get here differentiate log u and differentiate of log u, that means 1 by u du upon me del u upon me del theta equal to here differentiate of constant function 0 plus here differentiate of log sec n theta equal to 1 by sec n theta into sec n theta into tan n theta, and this function is also angle differentiate, that means n. Okay, chain rule, cancel out, we will get the result n by u del u by del theta equal to n tan n theta. Here cancel out n tan n theta, n tan n theta, and also again differentiate. Okay, so cancel out del u by del theta equals to u tan and theta. Okay, and differentiate again del 2u by del theta square is equal to del u upon with del theta tan theta tan and theta plus first term we catch, second term leave. After time first function leave, second function differentiate, then differentiate u, differentiate tan and theta, that means as here differentiate sec tan theta in differentiate, then u here constant function, that means n sec square n theta. Okay, here we will get the result, that means differentiation. Okay, we know that from differential equation of the orbit, from differential equation of the orbit, we will obtain a differential equation of the orbit del square u by del theta square plus u equals to minus fr upon L square u square. Okay, and put the result of del square u by del theta square. Okay, and here we will get the and get the force F. We will now leave. I will put and we will get the result. Here del square u upon del theta square, that means del u put del u upon del theta here. Let us put it here a equation, and here b from from equation here c put the value of del u upon del theta and del u square upon del theta square in equation C. Then we will find the result of u here u tan square and theta tan square and theta plus u and sec square and theta plus u equal to minus fr upon L square u square L square u square. इसीलिए I will written as u1 plus, also written as comma. Okay, will take common u, that means 1 plus 10 square, 10 square here common, 1 plus 10 square and theta plus u and sec square and theta. Now minus fr upon में l square u square and u sec square and theta plus u and sec square and theta equals to minus fr upon l square u square. Okay, here also we will take common, that means u sec square and theta, that means 1 plus u sec square theta, that means n equals to minus fr upon l square u square, and also cross multiplication, that means fr is equals to, okay, जो है l square u cube sec square and theta upon m minus, okay, and put here 1 plus and, okay, 1 plus from equation A, here let then here 1y u, here from equation A r 1 by r to the power u to the power n equals to 1 by r to the power n equals to 1 by a sec and theta. Okay, then we will also written as, okay, that means sec, here put n theta is equals to r a u to the power n, that means a 1 by r to the power n, a r to the power n sec and theta. Okay, sec n theta, and also written u to the power n. We will write here minus l u cube sec 1 plus n sec square n theta, that means sec square n theta square, sec square n theta equal to 1 by a u to the power n, that means a square u to the power 2n, that means a square u to the power 2n upon m. Okay, so u to the power 2n and 3. Okay, that means here where f r equals to minus l square u 1 plus n u a square u power 2n plus 3 upon m. Okay, here also written as fr equals to minus l square a square 1 plus n upon m into 1 by r to the power 2n plus 3. That means f r directly proportional to 1 upon r to the power 2n plus 3. Okay, and this is the attractive in nature. This is attractive in nature. Okay, second question I will discuss another next day and next questions of a central force motion, and at a time I will please I will end at a time class. So thank you.